In this video segment of the series of using and setting up the Instron 3369, I'm going to talk about the tensile test. A tensile or tension test is one of the first tests done in the Strength of Materials course. On this type of machine, it's one of the most common tests. It yields very useful information such as Young's modulus, ultimate, and yield strengths of various materials. For the Strength of Materials lab, we'll be testing test coupons that have this shape. This is referred to as a dog bone shape. We purchase these in various materials. We have aluminum, we have brass, and we have a mild steel in addition to other steel alloys. So we've got some options in terms of steel. But as I mentioned, I'll set up the machine. I'm going to assume that as you see here, the machine has no load cell and no attachments. That may not be the case. It may be all set up for you. If that's the case, then you'd be set to go, of course. But in case you have to put on the load cell and the attachments, I'll show you how to do that. And then at the end, I'll show you how to take those components off in case you're in a situation where you have to make a change and you need to take everything off. The first thing I want to do is attach the load cell, in this case the 50,000 Newton load cell. This is required for the tension test for the Strength of Materials. To begin, we want to make sure that the cross member of the machine is high enough such that we can fit everything in here. In a little bit later, I'll show you how to control the machine, because at this point in time you need to have the machine off because we're going to be making the connections, and you want to do that when the machine is off. We do that for the load cell and for the extensometer. So as of right now, the machine is off. Before I place this underneath the cross member, I want to point out that there's a very small pin that goes into a hole on this surface of the load cell, and that's done for alignment purposes. When you're taking off the load cell, you want to make sure you take that pin and put it onto the other load cell that you're replacing on the machine. I also need the large bolt to attach it. As I mentioned in the first video, the basics, you want to have two washers in place, one large and one small, and that's going to come, of course, from the top side of the cross member. I'm going to orient such that the pin is in the back. There are several holes underneath here that you can't see, but there's a pin in the back, or pardon me, a hole for the pin in the back that I'm going to align with. The load cell is fairly heavy, so if you need to, have someone help you. For now, I've got it thumb tight. It's definitely held in place, so everything is okay. It's not going to come off, but I do want to tighten it down now. In order to tighten it down, I'm going to use the torque wrench with the Allen attachment on the end. Now technically, the Instron documentation says that this needs to be torqued down to a certain value. For what we're doing and the fact that we're not approaching the loads even anywhere close to the 50,000 Newton capacity of this machine, you can tighten this down as appropriate or to a reasonable tightness. I'm going to go ahead and do it. You can see how tight I'm doing it, and as long as it's close to that, it's okay. So I'm going to give it one good tug. As I mentioned, that's okay for these tests. The next thing I'm going to do is attach the wedge grips. Those are necessary for the tensile test to grab the flat dog bone coupons that I mentioned. These wedge grips are heavy as well, so if you need assistance, have someone give you a hand. You want to have a 1/2-inch pin ready for this DM connection. You want to make sure that the check nut that goes up and down is all the way against the body of the wedge grip. We don't want that getting in the way. For the tensile tests, you want to make sure that they are oriented in this direction. That'll make a little more sense when we go to put the extensometer on. I'm going to slide the pin through. and put on the retaining clip. At this point, I want to take this check nut and I'm tightening it against the load cell. Whenever we're tightening the check nuts, we tighten them away from the wedge grip. The intent is to take out any slack like this, and you do that by tightening it against something other than the wedge grip, in this case the load cell, and at the bottom you're going to be tightening against the mount at the bottom. In order to tighten, I'm going to grab this check nut tool. It goes into the hole that happens to be on this side. Again, I'm tightening against this, so the direction I'm going to pull on it. You don't want to do that super tight. What I did there is just fine. For the bottom wedge grip, I'm going to check to make sure that the spring is inside here. That spring just holds the grip into place as I place it down there. Oh, before I do this, I want to make sure that the check nut is against the wedge grip. Placing that down there. And I go ahead and put in the pin and retaining clip. I always tighten the check nut against or away from the wedge grip. So in this case, I'm tightening it down. Take the tool to tighten it, and we're done. This entire length of attachments is referred to as the load string once we have the sample in place. And I'll be using that terminology potentially later on, so I wanted to point out that's referred to as the load string. For this lab exercise, we're going to use the extensometer, the most accurate way of gathering strain data. I'm going to show you a couple of things about the extensometer. Keep in mind that this does not have to be used for all tests. The crossmember on the machine has an encoder that can give position. Not the most accurate way, but certainly the easiest way. There are spring clips that hold the extensometer to the specimen. These spring clips can be exchanged for different sizes to fit different shapes of test specimens. Most of them are rectangular, but there are also circular cross-section test specimens, and so depending on what you're testing, you may be switching out the spring clips. In this kit, we have several different styles and sizes of spring clips. In order to change them, it's a toolless operation. You can squeeze right here on the spring clip to pull it out. Once you grab the new one, of course it goes back in the same way. While I have it off, I'll point out the knife edge on this arm. That contacts your specimen as well as the spring clip itself to hold it against that knife edge. And of course on the second arm there is another spring clip. In order to use this device, before we place it on the test specimen, we want to set the gauge length at 1 inch. And to do that, we use the plunger to plunge into a cone-shaped feature on the backside that holds those arms 1 inch apart. 1 inch apart. Once we place it on the test specimen, then we can release that plunger so that the arms can move and measure the strain. So again, in order to use this after we've taken and put in the spring clips, I'll push in the plunger. Now this is a little difficult to do, so I'll show you exactly how to do this when the specimen is on the machine. I don't have enough hands to do this, but essentially what I'll be doing is holding the plunger in, pulling these two spring clips back so that I can place this around the test specimen. I'm now ready to make the connections of the load cell and the extensometer. To start off with, I'm going to go ahead and hang the extensometer right here on the side of the machine. I'm going to feed the connector and wiring through the back. I'm also going to make sure that the wiring for the load cell is routed to the back. And I'll show you how to make those connections. I'm standing at the side of the machine I'm going to go ahead and take the cable that comes from the load cell. There's a strain relief loop. I'm going to go ahead and place the cable in that. Move it to the desired position. Down here on the side we have a connection that's labeled strain 1 and a connection that's labeled load. I'm going to go ahead and make the connection to load. This is a D-type connection. I want to make sure that I have the orientation correct. Go ahead and push that on. For the extensometer, I'm going to connect it to the connector that says strain 1. At this point in time, we're ready to turn the machine on. The machine will auto recognize the load cell and extensometer. It'll know exactly what they are and has calibration curves for them, and it'll be ready to use. After you've made the connections for the load cell and the extensometer, you can turn on the system. Now the system needs to be turned on before launching the software. If you launch the software first, it won't recognize the machines being on, and then an error message will come up. So once we've done both of those, turning on the machine and launching the software, only at that time does the switch work for moving the cross member here. So if I hit the switch now, it'll move. Again, if the software's not running, this will not work. We have some mechanical stops that can be moved along this column, the right column of the machine. Those can be placed wherever you like, and if the cross member exceeds that position with this pointer right here, it'll physically stop the system. I'm going to do an example. I'm going to place this top stop very close, so if I take and move the cross member up, notice it stopped on its own. We also get an error message saying that the load frame limit has been tripped. These are safety limits to prevent damage to the hardware. After I place my coupon in here, I'll show you why we want to set those, or where we would set those, and the damage we're trying to prevent. I'm going to hit OK to release that message. I'm going to move the cross member down. I'm going to move this lower limit for now because I need to load the sample. In this case, it's a piece of steel. Opening up the jaws so that they're wide enough. I want to make sure that I clamp no higher than about here. Now I need to move the head down to make sure that I can clamp, watching to make sure it doesn't crash into the sample. By the way, this switch for moving the head up and down increases in speed the longer you hold it down, obviously to some maximum, but be careful. And I tighten down the upper grip as well. I mentioned the hard stops. I'm going to go ahead and take the lower one and place it right here. I'm going to place it very close to the arrow. There's no need for the system to go down any further because we're doing a tensile test. If we go down any further, we're going to take our specimen and collapse it in compression. We don't want to do that. As far as the top limit, I'm going to take it and give myself a couple of inches, maybe even more. It doesn't matter until we start getting up towards the top of the machine. This upper limit just prevents the cross member from going up too high. Or if you had the oven here, then obviously that would be important. You don't want to hit the top of the oven. But it's not critical to have it very close. We got to make sure we have enough room for this to stretch. We're just trying to prevent any damage to the top of the system. So right there is just fine. I'm now ready to put the extensometer on. First thing to do with the extensometer is to press the plunger in, setting the gauge length at 1 inch. I'm going to reach around and pull the spring clips to give myself a little bit of space between the knife edge and the spring clip. Trying to get it in the center of the specimen. I let go of the spring clips and then I let go of the plunger. Once the spring clips have tighten down against the specimen and the knife edge on the back side. Now the gauge length of 1 inch won't change until we start pulling on it and the specimen itself starts to stretch. I want to point out that there are two different ways of determining deformation of the sample. The simplest way is using the position encoder on the cross member itself. The encoder itself always is giving the system the position of this cross member. Now, if we had the desire to measure strain for a test coupon, we have these two options I'm talking about. You can take the information from the cross member position. That deformation then can be used by calculating the strain from the gauge length of this. Now the question becomes, what do you use for the gauge length? Do you use this entire section or some other value? Also, when you're measuring the position of this, it also is measuring any stretch in the whole load string. Now obviously these components are much stiffer than this component here, but if there's any measure of slack anywhere in these components, it's gonna alter your calculation in a negative way for the strain itself. The extensometer is always the best way for determining strain if it's possible to get onto your coupon. There are some downsides, some disadvantages. You can't leave this on for the entire test. We have to remove it well before the sample breaks. If the sample breaks with the extensometer on it, it might break the extensometer, so that's one downside. With the encoder for the cross member, we can let that be recording data throughout the entire length of the test. So that's one advantage of it. But we're going to be using the extensometer for this particular test. I'm ready to run the test, so I've opened up the Blue Hill 2 software. From here, I'm going to go to the test option. In this particular video demo, I'm not going to talk too much about setting up a brand new profile. Rather, in this case, we're going to open up an existing profile that goes along with this lab for Engineering 151. When I open up Blue Hill and hit the Test tab, I bring up a box here that allows me to pick from different profiles that have already been created. I've purposely cleared out this list to show you what to do in case you have to start from scratch in selecting the folder and then the file. With nothing here, I'm going to go over to the Browse button. And on the C drive, let me go back to the C drive. In Engineering 151, there's an Instron test files, do not modify folder. In that, I'm going to select the Engineering 151 tension with extensometer, and that is built specifically for this particular lab. This particular profile is going to save all of the raw data that can be opened up in an Excel spreadsheet. It will also save a couple of other files, one that has a simple graph that is plotted. And in this particular screen here, I'm going to indicate the file name that is set up to store the folder and the file for the Excel data. Now, depending on who used this last, that file is going to be sent to a variety of locations. So instead of just accepting the output folder that is the default, I'm going to go over to Browse to indicate where I would like this data to be stored. I've logged into this computer as myself. You as the TA will also be logging in, and so if you'd like, you can place this on the desktop. In the end, you need to get the data to the students through, for example, UCM crops, and so in that case, as long as you know where the data is going, you can take it to upload to crops. I'm going to go ahead and pick my desktop. I'm going to indicate a file name as tension and just leave that as such for now and hit save. It automatically jumps to the next screen, so you don't have time to make any changes. You could go back, but it doesn't really ask you if you're sure or anything like that. From this screen, it's going to ask us for the material that we're testing. The reason it asks for that, it will drop it into that simple report or simple graph that I told you that will be exported at the end with the raw data. In this case, this is steel, and it is 1018, cold drawn. That's what CD stands for. In the next screen, it's going to ask me to zero the load and strain values and reset the extension value. You'll notice that up at the top of the screen there are some values. For example, for the load, 118 pounds, the strain has a negative. These values need to be zeroed out. And so in order to do the load and the strain, I've got two hot buttons programmed. So balance the load, we'll set that to 0, and the strain will set to 0 as well. It's asking us to make sure that the specimen is properly installed in the test machine. We've done that. The other thing that I want to do at this point as well is I want to make sure that I have zeroed my extension. So let me be clear about what the difference is between this extension value and the strain value. The strain value is directly being reported from the extensometer. It's in percent and it is based on a 1-inch gauge length. The extension value, on the other hand, is a position of the cross member. Now that position can be reset to 0 at any position. Right now it happens to be set at 0, but it could read 5 inches right now depending on where it was previously set as 0 and how much it's been moved by a user who previously used this. So let's say that it had 5 inches there and I wanted to reset that value to 0. There's a reset button down here, and again it's not going to do anything because it already reads 0, but if I hit reset it would set the extension to 0. I want to caution you though before you use these two buttons here. You can get yourself in trouble because there's a button right above it that says return. That button does this. It takes, for example, if your extension was 5 inches right now, so instead of 0 up here, it said 5. If you came over and hit return, it's going to send the cross member back to 0, wherever that might be, which is 5 inches away. And if you have a sample loaded in the machine right now, it's either going to pull it apart or crush it, depending on which direction it goes. So be very careful when you hit either of these buttons over here. Think twice about which button you're hitting. In this case, again, the reset is what I'd like. You may ask, when would I ever use return? Let's say you're breaking several samples and they're all the same length. After you break one sample, let's say the cross member has moved 1 inch, and you're ready to take out the old sample and put in a new one that's not broken, you can hit the return button and the cross member will go back down to the original position, ready for you to put in the next sample. And now I'm going to go ahead and hit the start button to start this test.